Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.
All right, in this lesson today, we are going to just have a brief introduction to parabolas. Okay, I've been talking about this word for a while, and you might have heard it before, but okay. So parabola, it is not pronounced parabola, even though that's what it looks like. If you want to be funny, you can call it a parabola, but it's a parabola. Okay. I do not know why it calls parabola, why it's called a parabola. Extra credit. Haha, JK, not really, but do some research if you're curious. If you're not, that's fine. Okay, but let's talk about parabolas, and we're specifically, that's probably after, linear equations, lines. This is the second most popular type of graph and function, and this is pretty big for us. So everything that we've been working on with, x squared, those are quadratic functions. The quadratic function, the graph of a quadratic function is a parabola. Okay, so the graph of a linear function is a line. Okay, so that's where that comes from. But they have some pretty unique characteristics that we're just going to talk about. I have 3 different parabolas on here, and people are going to say different things. Just some vocabulary for us right now. Okay, so like this green graph over here, people are going to say that something like, oh, well, it opens down. Okay, because look, it's going down, so it's opening down. And these other 2, they open up. Right, the red and the blue one both open up. All right, what is also really neat about these things, they have a vertex. Okay, vertex is going to be right in the center. Okay, so we'll do this one, do this red one. So here's my vertex right here. Okay, this point is the vertex of this parabola. All right, and we can actually figure out what the value of this vertex, this point, this ordered pair. So it's 1, 2, 3, 4, comma, -1. All right, that's that vertex. I can do the same for this one. Sorry, they are not perfect, but so this one is -1, comma, 2. And this third one is about right there. So that's close enough to 1, 2, 3, 4, 5, 6, -6, comma, 2. All right, so every parabola will always have a vertex, no matter what. Another neat thing about parabolas is that they are symmetrical. Okay, they're symmetrical at the vertex. So we have what is called the axis of symmetry. So for this red, my red parabola, I have this invisible line that kind of goes through the center of it. That's the axis of symmetry. AOS from now on, because I'm not going to write it out every single time. And it's at x is equal to 4. It's a line, okay, so it's not going to be a point. It's a vertical line, which means it's going to be x equals something. All right, and for this blue one, here's its axis of symmetry right there. It extends forever, but I just don't have the space. This axis of symmetry, x is -1. It's the same as the x value of the vertex. All right. And let's go over to our green one. Let's see, my axis of symmetry here is x is equal to -6. All right, that becomes important to just be able to like characterize the graph. And I don't know if you notice about these like the vertices here. Okay, like the red and the blue, the vertex is at the very bottom, like kind of like a bowl, right? And it's just, you know, it's at the lowest point. So this is considered a minimum, okay? That vertex here is a minimum, just like this one. It's the lowest point because the rest of the graph is above it. And for the green one, this is actually a maximum value, okay? Because it's all the way at the top. Like that's the peak height of the function, and then it's going to go back down when we go from left to right. Okay, something that is not unique to parabolas or quadratics is the idea of intercepts. Okay, so I can have an x-intercept and a y-intercept, right? Remember, the x-intercept is where the graph crosses the x-axis, right? And the y-intercept is where the graph crosses the y-axis. So for my red parabola, I actually have two x-intercepts, okay? That's what makes quadratics a little different than linear functions. Lines will only cross the x-axis once. It will never cross twice. Parabolas could cross it twice, okay? And look at this, it does. It crosses it twice right here. This is x is equal to 2. And this one is x is equal to 6. And it should be right in between. My vertex is at x is 4, so it is right in between those two x-intercepts. Same with my green. All right. That is x is equal to -7. This one, x is equal to -5. All right, it's splitting that in half. Splitting the parabola in half. All right, now look at the blue graph. The vertex is above the x-axis and it opens up. So notice the graph never crosses the x-axis, so it doesn't have any x-intercepts, which is okay. It just doesn't have any, so you'd write none, or NA. All right, so if it can cross the x-axis, it might also can cross the y-axis. All right, so the y-axis, the y-intercept. So let's look at the y-axis over here. So it's going to cross the y-intercept right there, or the y-axis, that's the y-intercept. 1, 2, 3. Y is equal to 3 for the red, 2 for the blue, and we can't tell what it is for the green yet. All right. They will only ever cross the y-axis once. So this is, the green one is probably gonna, like, you know, it's gonna keep going down forever and probably cross it at a very, very negative number. All right. Now I want to talk about maybe some like practical applications for parabolas and like what people even use them for. Okay, so it's really just interpreting graphs. You're not having to graph yet. We're just going to be looking at a graph and talking about it. Okay, so let's say you kick a soccer ball. Okay, what does that look like? You kick it with all of your might. What is that going to look like? Maybe, you know. So I've drawn this this graph. Okay, the y-axis is going to be represented by height. Okay, we'll say this is in meters. Okay, not like it really matters all that much. And then time is in seconds. Again, not like that really matters, but just so we have an idea. Okay. So, and the graph looks like, so when you like kick something, right, it goes up and then it eventually comes down. Yeah, because that's how gravity works. All right. So let's say it looks like this. Bad graph, but it doesn't matter. Okay, I want to ask you some questions. We can talk about this. All right. Okay. So remember what we talked about before. We have a vertex. Okay, the vertex is right here. Yeah, that's my vertex. All right, that's at, we'll say, like 2.2, why not? That's my x value, 2.2 seconds, and let's see, 1, 2, 3, 13 feet. Okay, so what's the maximum height of the ball? It's right here. This is my max height. Oh, not feet, excuse me, meters. Okay, 13 meters. All right, how long was it in the air when it got to that height? Oh, well, that's just the x value of the vertex, okay? Let's see. That's what, 2.2-ish seconds? It's all right. It doesn't have to be perfect. 2.25, why don't we say that? Oh, duh, it would be 2.25. Okay. So, now, what another thing that we might need to know from this is like, how long did it take for the ball to hit the ground after we kicked it? So we kicked it right here, right? That's time is 0. Okay, and it traveled up and down, right? It also went, like, it went some distance, right? But that doesn't really matter for us. We're talking about just height, like how high it went. Okay, how long was it in the air? Well, if this is 0 feet and 0 seconds, this x-axis, where's the only other time it hits the ground? Hits the ground right here. Hits the ground after 4 seconds. So the ball had 4 seconds of air time. I don't know if that's realistic or not, doesn't really matter. Okay. You can also say that, what can we say? After 2.25, it really should be 2 seconds if this is accurate, but just based off my graph, it's not super accurate. After 2.25 seconds, the ball reached its maximum height. Right? Because at that point, it started to come back down. Okay, we're not in space. We have gravity. It's going to come down. All right, let's look at another type of example. Let's talk about money, okay? Similar idea. I think the example that you have to do, the problem that you have to do is talking about like an app and how much they're going to charge for the app. But I'm going to do something else so it's not the same. Let's say I'm selling whatever. Okay, that's my item. It's whatever. Okay, and we haven't sold it yet. Okay, this is essentially a just like an estimation of profit, right? When we like create something, right? Like we want to make money. Yeah, like that's why else. Let's do this in why else would I want to do this if I wasn't going to make money? Okay. Okay, so on the left-hand side, right, I got like 5, 10, 15, 20. I don't know why I went up to 30, 40, 50. Just getting ahead of myself. 25, 30, 35. Okay, so this over here is how much money I could potentially make. My annual profit. All right, this is in billions of dollars. Billions and billions. All right, of doll hairs. Okay, so they're going to be 5 billion, 10 billion, 15 billion, 20 billion, so on and so forth. Okay, down here is my unit price. Like, how much am I going to sell a whatever? Am I going to sell it for $1 each, $2, $3, $4? Okay, like per item. Like, they're going to go to, like, you're going to go to the store, you're going to buy my whatever and pay this much. One of those, whatever we decide, right? This is kind of, the whole point of this is to figure out, well, how much, what should we sell our app for so we can see how much money we're going to make. All right. So kind of the same idea as before. I'm going to do this, explain it a little bit differently. All right. So let's look at this right here. If we sell our whatever for $1 a piece, how much money will I make off of it? $0. 0. I will not make anything. Like, there will be no profit. Okay, so no profit for unit price under $1, right? Because anything less than that is just, I'm losing money at that point, right? That's why it's negative. We can't, like, we can lose money. I can't sell something for negative dollars, but I can lose money. No profit for unit price under $1. Okay. Or over, let's look at this. We'll say that's 11.5. Or anything over $11.50. Because look back at my graph, at some point it's going to go back down. People, like, you're not going to buy something that should be $3. You're not going to spend $100 on it, right? Like a pencil. Pencils are not that expensive. Would you spend $200 on a pencil if somebody was selling it? Maybe, I don't know. I hope not. I mean a regular pencil, not like the Apple Pencil I'm using. Okay, so let's get back to this. All right, so we know that, let's figure out like our max profit. So our max profit is right here, yeah? According to this function, I'm not going to make more than, let's say that that's 31 million. Or billion. 31 billion. Okay, well, at what price do I need to sell my whatever's at? So I gotta go straight down for my vertex, and we'll say it's at 7. If I sell my whatever's at $7 a piece, according to this graph, I should make $31 billion. That would be nice, whatever this is. All right. If let's say I only wanted to make, say I was, what is this, $17.5 billion? Well, then I would need to sell it at $3 a piece. Okay, and then over here, if I decided, you know what, I'm going to sell it for $10.5 a piece, this is how much money I would make. I would make $10 billion. All right, so that is kind of how parabolas can work for us in these types of scenarios, okay?